Yeah, that's amazing, guys. And we will be starting within few minutes. Let everyone join. And if you guys are excited, so just let me see how you guys are excited. Just show me a thumbs up in the chat so that I can see how much excited you are. All right, and then we will be starting. Amazing, guys. Amazing. So that's what kind of response I always want in my class. And I promise you guys, today's this live session gonna be so much fun because today we will be talking about robotics, electronics, and these things which really fascinating, you know. And before moving on, let me first introduce to you Savishkar. Savishkar is a non-profit organization which works like all over India with the universities where Savishkar India promotes entrepreneurship and innovation throughout all the colleges campus. And Savishkar CUK is the organizer of this event. And we are really, really thankful to Savishkar India and Savishkar CUK for giving us this wonderful opportunity to host this program. And yeah, let me introduce myself. Myself, Progya Dipta, or you can call me Progya. And today, today, we gonna rock the session where we will be starting with robotics. So let me share my screen. Yeah. All right, guys. So I think you can see my screen, right? Okay. All right. Yeah, that's fine. So, before moving on to our session, let me tell you that how our session's gonna be, how this 4 week workshop going to be held, right? So the first thing which is today is our first session, and we will be having 8 sessions in total like this. And every week we will be having 2 classes, 2 live classes, and after the classes you will be given one assignments uh, after each sessions, and uh, after you complete all the assignments, you will be awarded with the certifications, which will be provided by Savishkar India along with Savishkar North Karnataka. So I really welcome you all to this wonderful session, and let's begin without wasting any further much time. So again, I need to see your thumbs up, guys, and let's move into our session. Amazing. Okay, guys. So yeah, that's amazing. That's amazing. Let's move on to our session where we will be starting with robotics. Now, let's talk about today's mission. Our mission is to start from the zero where you are having zero experience on building prototypes, working with Arduino, working with building robots, and what is robotics, electronics, what is programming, you don't know, you know nothing about it. Okay, and it's okay. And we are considering that you are a complete beginner, you don't know about coding, you don't know about Arduino, robotics, nothing. Okay, so just considering that we are moving toward our session, and it's my promise to you that I will bring uh you know all the amazing things to you in this sessions. Okay, and it's my promise that after completing all the 8 classes you will be able to innovate, you will be able to build your own prototypes and work with all the electronics components. All right, so basically, We will start from the basic level, and then at the end of the session, at the end of this workshop, you will be able to, build your own prototypes for the hackathons, right? And this course we have introduced just because of one reason, that we have seen many students before participating on hackathons, they used to face, or they used to feel like we are not capable enough of, uh, participating in. Oh, screen. Uh, yeah, guys. So is it better now? Can I have some feedback? Uh, so sorry, guys. It was some technical issues. I hope you can understand. Yeah. Okay, that's amazing, guys. So let's move forward and okay. So not an issue. Let us start from the beginning. So I was discussing about what's our today's mission is in this session. So our mission is to take you from zero to hero, right? And we will be starting where you are having literally no idea about what's coding is, what's Arduino is, what's robotic is, and we will make you hackathon ready, where you will be, more confident over participating in hackathon, and you will be ready to build your own prototype. And also, guys, we are keeping this session in the language English because we are having students from all over India, somewhere from different parts of the India. So, I guess it's better to have a language where everyone can understand, right? So, I hope that's not an issue. And yeah, okay. And I would also request to please use the chat. To connect with me if you're having any doubts, if you're having any questions, you can ask me. I will definitely try to answer. Yeah, fine. Okay. Yeah, I request who is that bunny, please, to make sure get the certificate. Yeah, so the certificate you will be getting, a e-certificate will be given to you through your email, and that will be sent to you just after completing all the assignments or assessment which we will be providing you after each sessions. So after each session, you will be given some assessment based on the session and the session's contents, right? So, after completing all the 8 assignments of the 8 lectures, you will be given the certificate. Okay. All right, guys. So now let's start with our session. So our path is to start with block-based coding, where we will be, even if you are not familiar with coding languages or you are not good at any coding languages, but still it's very easy and fun to do. Where we will be just, grabbing some blocks and putting them together to build our code to work with robotics or Arduino. All right. And after which we will be doing a virtual simulation. For example, if we are working with Arduino, we will be doing interfacing LEDs. We will be interfacing all the different electronics components virtually without the need of actual components. All right. And after which we will be moving forward learning or knowing the C programming, the basic C++ programming which we need in order to work with Arduino. All right, guys, and at the end, we will be understanding how to use AI tools in order to generate the codes. So you even don't need to write the codes. You just have to have the ideas, and then you will be able to work with Arduino and build your own prototype of that idea. Yeah, so the assignment will be given to you just after completion of this session. It may take 1 day time, but you will get it. And before the second session, you have to submit that, and very soon you will be provide we will provide you the schedule of which date we're gonna have our sessions, and the recording will be there in the YouTube channel, so no need to worry about that. But you have to make sure that you are participating in the live class in order to have a live interaction along with like doubt solving. All right, so let's move forward, guys. uh, Now let's talk about what is robot, right? So as you know that our session will be based on robotics. So before we start with robotics, let us know about what is robot. So regarding the attendance, it will be as per your assessment. So the whoever will be completing the assessment will be given the attendance, and once you complete all the assessment only, you will be awarded with the certificate. All right, and definitely if you are not following the session, you will be not able to do the assessments, right? Okay, so you have to score at least 70% in the assessments. So for that reason, I would suggest you to just be on the sessions. All right, so follow up the sessions and then give the assessment, and you will be getting the certificates. All right, I hope it's clear. Now let's come back to our topic, which is about robot. So robot are basically a machine, right? But special kind of machine which can sense, which can think, and which can act. Okay, so basically, it's all about building a machine which can sense, which can think, and which can act or perform as per we want them to do, right? So, any physical action, for example, if we want to turn on the lights on and off automatically, it will be a part of act, right? And if we want the robot to think, like if the distance between me and the wall is 10 centimeter, so I have to stop, right? And this the sense part is basically about whether my machine is able to get the real life data. Is it able to find the temperature, how much what's the temperature of my uh, room, what's the temperature of my workplace, or what is the humidity. All right, uh, so this is all about what is a robot. Now let's talk about microcontroller. So, if you are entering in the field of robotics, if you are entering in the field of electronics, you must need to be familiar with the term microcontroller. So, what is microcontroller? So, we can think the microcontroller as a brain. Okay, so microcontroller can be called as the brain of electronics, where it gives the capability of thinking and acting for a robot, right? So if you are building a robot which can, walk, or which can, you know, uh, you know, run or talk, they must have a brain. But can we have a human brain in a, computer or in electronics? No, it's not possible, right? So we need microcontroller, or you can connect it with as like the CPU of a computer. So we all know that what is CPU, right? If we known as CPU is the brain of a computer. So similarly, microcontrollers are the brain for electronics. Okay, and I hope that you all are having your notes, right? So please have a notebook beside you. Just note it down. What are the important points which we are discussing, right? And it's basically a tiny computer, okay, on a single chip, and which helps you to work with electronics, which helps you to give intelligence or computational power to the electronics. Okay, so if we talk about a motor, it doesn't work by itself. Okay, so we need to have something which can control that motor to work when it's needed, to spin a motor when it's needed, right? Or that's the need of a microcontroller. And microcontroller have some specification, like it's have one program and it can run over and over and very fast. So I would like to give you a very amazing example. Like, you have seen lightings in various places, right? Whenever we are having Christmas or any Diwali festivals, so what happens, people used to decorate their house with a different type of lighting. And you have seen that those lighting are changing automatically, right? Sometimes it's blue, sometimes it's red, sometimes it's a different combination of colors. So that's how a microcontroller works. It works as a brain which controls the sequence when to do what. It helps the electronics component to act. All right. So it's all about microcontroller. Now, let's talk about our microcontroller on which we will be working on, and that is Arduino. All right. So Arduino is one of the famous microcontroller in the electronics community, and why it's famous because it's open source. And meaning of open source is basically some things which is open to all. So anyone from the internet, anyone who is smart enough, they can work with the microcontroller Arduino, right? You and it's very cheap, which comes under 250 to 300 rupees in the market. You can just buy one and you can work with it. And also we will be showing you how the microcontroller looks like, and different size of microcontroller, of different types of microcontroller which are present in the market. And so it's one of the popular microcontroller in the world for the beginners or the people who need to build prototypes. All right. So this is a microcontroller, or this is the brain of every project which we build. All right. So now I'm gonna show you uh, the microcontroller, how it's look like. All right. So uh, just a minute, guys. All right. All right, guys. Just a minute. We are setting up the cameras, and okay, guys. We are having some problem. No need to worry about that. Let me show you in the main camera, and let me know whether you can see or not. Yeah. So can you see? This is known as Arduino, which look like exactly this. All right. Now, this Arduino is pretty amazing because it has the capability of not only, blinking LEDs, it can also get information from the real life environment, right? So it has, you can see it has five. Okay, I don't know whether you can see or not. Yeah. So here are the pins of this microcontroller Arduino. So this Arduino is having some pins which is also written which types of pin it is, right? So here you can see that this are the power pins. Okay, and this power pins is basically powers your electronics components. Okay, so here you can see we are having 5-volt power output, we are having 3.3-volt power output, and then we are having ground, GND, which is the ground or the negative terminal. Okay, so whenever you are dealing with any project, you need some power output like ground, or 5-volt or 3.3 volts. So different components work on different voltages, right? So if you are talking about some motor or servo motors, so they basically work on high voltage, like 5-volt, 4.5 volts, and some other electronics component like LEDs, they work with 3.3 voltage, right? So that's why we need different power outputs or power source. All right. Okay, guys, just a minute. Okay. All right, guys. Yeah, let's move forward. So here, yeah, definitely we will be sharing you the contents which we are showing, the PPT which we are showing to you. So no need to worry about that. All right. Uh, just be with the session, and once we end the session, and we will share the PPT with you as soon as possible. Okay. So no need to worry about that. All right. Now, uh, okay. Just look at this, Arduino. Okay. Yeah. Okay, guys. I think it will be better if I use. Okay. All right. Yeah. I guess it's better. So now you can see. Okay, it's blurring. Yeah. I guess. Okay. Yeah. I guess you can see it clearly now. Okay. So here we're having different pins in this microcontroller. All right. So where we are having the power pins, then we are having the analog pins. And these analog pins are basically, you can say they are responsible for getting the, analog data or the data which we get from our real life environment. All right. It's about the humidity, voltage, or, frequency, everything which we got from this analog pin. Right. And if you see this side, so these are the pins which are known as digital pins. All right. So as you can also see, it's written in the microcontroller that these are digital pins. And in this digital pins, we are having total 13 digital pins. All right. Starting from pin number 0 to pin number 13. And these pins are used to control the, electronics components. All right. So, for example, if we are controlling, if we need to control a LED, if you want to turn it on, turn it off, then we need it. All right. So, guys, uh, as you can see, this is what a microcontroller look like, or a Arduino board look like. All right. That's amazing, guys. But now I want you to show you something amazing, and that is this. Can you see this, guys? Let me know. Uh, any idea what is this? Any idea? Let me see who can identify what it is. All right. Okay. Let me make it a little bit closer. It's lagging because of the hotspot. Connect this with that hotspot. Uh, yeah, that's amazing. So exactly, it is Arduino Nano. All right. So yes, now the thing is, this microcontroller and this microcontroller, they work their work as same, their works same, they're having the same, speed, same memory, same capabilities, but the thing is it's smaller and it's bigger. All right. uh, Yeah. So uh, definitely it's not a chip, it's a microcontroller. And okay, so we are having some amazing responses. Someone is saying it's light detecting registers. Uh, we will see whether you're correct or not. So yeah, definitely. After a few slides, I'm gonna show you uh, different, microcontrollers and different components. And that time, I'm gonna tell you how and which one looks what, right? So yeah, I should move it. Okay. All right, guys. So I think we can now. Yeah. So guys, I think now my camera is visible to you. All right. Uh, Position. Yeah. Okay. Yeah. I think now you can see, right? So this is the microcontroller, and this is our Arduino Nano. All right. So now we will be working on this, and we will, understand how to work with this kind of, microcontroller. Before that, I would like to show you. All right. So let's come back to our slides. Now we will be looking towards what are the various components present in the electronics world. All right. So before working with Arduino, before working with robotics, how to build robots, first we have to have an understanding over what the components which we need in order to work with Arduino or to build a robot, right? So for that reason, I have categorized some of the basic components which we need in order to start with the robotics. All right, and here I have categorized is in the this way, that the microcontroller which we will be using in our this session is Arduino Uno, and like I will also tell you how to use Arduino Nano, and then we will be knowing how to work with like breadboard, then jumper wires, and then LEDs, right? So we'll be I will show you different LEDs, the passive resistors, the digital input, which is a push button, or a 7 segment display potentiometer, or small servo motor or robotic sensor. So are you guys excited to see how this components looks like? And I will show you exactly how each components look like. And yeah, just give me a second and let me show you how different components look like. All right. So here, all right, guys. Now let's see each components. So our first component is definitely the Arduino board. This is the Arduino board, all right, and also known as the microcontroller, all right. And then we are having our jumper wires. Yeah, all right. So just let me remove the background. Yeah. Okay, guys. I guess you guys can see me, right? That's enough. Now, let me introduce to you breadboard, right? So, for an electronics engineer or someone who is enthusiastic about electronics, this is the workspace for him, right? So this is known as the breadboard, and this is the basically the workspace where you build all your prototypes, where you build all your projects. So this is known as the breadboard. And then we have our connecting wires. Okay, so these are the connecting wires using which we connect our components with the breadboard and also the Arduino pins. Okay, so that's about the Arduinos. And now let me show you some components. All right. So starting with the LED. So I know this is the most, popular components of the electronics. So I know, I think every one of you is familiar with this particular component. In your childhood, you must have played with this component, all right? So the duration will be till 7:30, as we have some, issues with the internet in the beginning. So now, as you can see, this is the most popular component of electronics. That's the LED. LED. All right. And then we are having push button, or you can say a switch, right? So this is called the push button, which is used to, turn on, turn off the circuits. All right. Uh, and you can use this to interface any LED or any electronics component. It can act like a switch. All right. Then we have something which you must have seen in many places, starting from your bike odometer, speedometer, and many different places. This is known as seven segment display. Okay, or in short, we call it as SSD. All right, so you can show any digital, decimal numbers or integer like 1, 2, 3, 4, up to 9. All right. So you can show just like blinking the individual LED, which you can find in the this SSD. Okay. And this individual LEDs are, having their own names like LED A, LED B, LED C, LED D, and LED F, right? So total seven. This segment is formed with total seven individual LEDs, and blinking this LEDs or lighting this LED in different pattern, will be able to see different numbers. All right, and also few letters also we can write using this SSD like A, B, right, C. So this is about the SSD, and this is also a very popular, electronics component, which is the keypad. Okay, where we can get the input from a user, from starting from 1, 2, 3, 4 numbers to the letters A, B, C, D, star, and hashtag as to special characters. All right, guys. So I hope you are getting it. You can see it clear. Then let me show you some amazing components. Like this is known as a servo motor. Okay, and in every robotic project, like building a robot which can walk, which can run, which can jump, they all use this micro servo. Okay, micro servo motors. And this micro servo motors are basically a motor. It's de- it's basically a motor, but it has degree of motion. So you can control how much this motor can rotate. You can turn it 30 degree, you can turn it 90 degree, you can turn it 40 degree, right? uh, okay, okay. No need to worry, you haven't missed much. What's your name? Okay, so yeah, so you haven't missed much. We are just introducing you to the components of electronics or robotics. All right. So this is about uh, what do you say? A microservo motor. Then we are having gear motors, which usually we use to build our, you know, uh, like robotic, rover, or which has wheels. That can be a remote control car, or you can build many amazing things with this kind of motors. So here it gives you the number of rotation or RPM. You can control the number of rotation or RPM or the duration of time till which you want to run this motor through a microcontroller. All right, guys. Moving forward, we are having our sensors, right? So this is known as the ultrasonic sensor, all right? And this ultrasonic sensor is used to measure the distance uh, between you and any other place, all right? For example, if it's just like a sonar, you are basically, the sonar, what it does, it finds the distance between you and your enemy, or maybe to navigate or to find some other vessels in the sea. We use sonar, right? So it's emits ultrasonic sound, and it's transmit and also receive the ultrasonic sound, and using that method it's find the distance between objects, right? So yeah, that's about ultrasonic sensor. And I guess someone was talking about I guess the light detecting diode, right? So actually that's not light detecting diode, it's light dependent diode. So this is known as a LDR sensor, or light dependent resistor, right? So how it works is, it's basically changes its resistance value whenever a light falls into it. Okay, so this is known as LDR sensor. So we have two sensor, that is ultrasonic sensor, and another is LDR sensor. So these are the basics component, and also we need our battery in order to power our projects which we will be building, right? So let me know, guys, are you finding this session interesting, you are feeling pretty bored? So let me know in the comment. Just give a thumbs up so that I can understand you are not sleeping, you are enjoying the session. All right, so let me see, guys. Let me see the response of you. Yes, amazing. Yeah, you are right. It reflects and senses the frequencies. Yeah, you're correct. And this is how the ultrasonic sensor work. And yeah, guys, there is a lag between you and me. When you are typing, uh, I'm not getting that message, immediately. So definitely there is a lag of 20 to 25 seconds. It's completely fine. Amazing response, guys. So let's start and let's continue with our next part. So as now you are familiar with what are the components in electronics, now we will be moving forward how to deal with those components, how to work with those components, and let's see how to work with them. All right, moving forward, let's us know about Pictoblox. Okay, wide awake till now. That's great, and I will make sure to keep you awake. And let's see the next part of it, that is Pictoblox. All right, guys. So let me see your response. Have you guys heard about Scratch before? Scratch programming, or you know the topic Scratch, where let me give you a hint, where people can just drag and drop blocks, which you can see here, and they can build some programming algorithm. They can build wonderful games, stories, and those things, right? So Right now, as I have promised, you need not to have knowledge about what's coding language is, what's which coding language you need to start with, or are you having some knowledge of C++ or Python or any other programming language. So because of that, I am starting with Pictoblox. Okay. So yes, so it's pretty similar to Scratch because it uses the similar technique of drag and drop the blocks and then you can program. All right. So it's amazing if you are knowing all the programming language. It will be very easier for you to understand and be in the station. And also for those who doesn't know programming language at all, it's also fine for them. All right, guys. So let me know whether you guys have already installed this Pictoblox in your computer or not. Or should I give you demo how to install it? um, I guess it's better that I can give you, uh, a tutorial how to install it. So definitely, I want to do that, and let me let me help you with. All right, guys. So I will be sharing my screen where I will show you from where you can install it. Okay. Um, yeah. Fine. So guys, let me share my screen and cam. All right, guys. So here is the website where you can, you know, uh, install. Uh, so this website is known as, Stempedia. Okay, where which link has been sent to you in the WhatsApp group. You can check it out, and also it's in the description. So once you scroll, you will be able to find the Windows installer, and from where you have to download the installer.exe file, and according to your OS operating system, just download it. I'm having Windows 11, so uh, just a minute. Yeah, got it. So here it will show you that you just click on no thanks, I just want to download Pictoblox. Okay, rather entering your name, email ID, or country, just say no thanks, I want to download Pictoblox. And once you click it, it will automatically start download, and it's downloading, I guess. Yeah, definitely. uh, Once it's download, yeah, once it's download, uh, it will take some time, like 1 minute or less. And once it's download, you can just install it, and I will show you how to do it. No need to worry about that. So yeah, until which it's downloading. Yeah, it's done, almost done. 4 second, 3 second, 1 second. Yeah, done. All right, guys. So my Pictoblox is downloaded now. Now I have to just click on it, setup. Yeah, okay. Now you can see, just you have to click on install, and it will start installing. It's pretty easy to install it, so no need to worry about that. Uh, as I'm also doing, so you can see how to install it. Hello, Rajak. How are you? Buffering again? I don't think so. Please check your internet connection. Okay, yeah, maybe it's happening. I'm sorry for that, but it will happen sometime. We can't do much about it, but we are really sorry for that. And if you miss something, uh, definitely I will repeat that part again. So no need to worry about that. All right. So if you find anything difficult, or if you find that you are not understanding that part, I will be helping you. All right. Yeah. So as still our installing part is happening, let's work on another part that is about WokV. So you just have to type WokV, WOKWI, in your Chrome. Just click on it. And the first website which you will be getting, that is https wokv.com. Click on it. All right. Just click on it. And you will be, you know, coming to this website. All right. Basically, WorkBee is an online platform where you can simulate your Arduino uh, without having to install anything, right? So you just have to click on Arduino Uno Mega Nano. So it's basically offers all these three categories of or the types of Arduino. So you just have to click here and you have to scroll it down and start from scratch. You have to click on Arduino Nano. So if you are working with Arduino, Uno, you just have to click Arduino Uno. And if you are working with Arduino Nano, you can click on Arduino Nano, right? So right now we will be working with Arduino Uno. So just click on it and it will show you a simulation. And whatever components which we have seen in just a few minutes ago, the same components you can get in the simulation also. So for example, we have seen uh, ssd, right? So we have seen leds, right? So these are the led. Okay, you can change the color, whatever color you want, right? You're gonna have white, orange, blue, or red, whatever. And then you can add a push button. All right. So this is a push button, and also you can change the color of this push button, whatever you want. You can have registers. Okay, these are the registers. You can change the resistance value. Then you can have uh, you know like seven segment is display, the seven segment display which we have discussed. Then you can have other components like if I say uh, keypad. Yeah, so here you can see we also have the keypad. So all the components which we have seen in the real life, we can simulate all those things here. All right. So now uh, this is about the simulation workflow. And yeah, so our installation part is almost done of the Pictoblox. So you just have to click install and yeah, it's installed, right? So I got it. So now we have to just finish it off and you can just remain it checked so that it will turn on. It will run that particular Pictoblox. Yeah. So now as you can see, our Pictoblox has been installed and you are pretty much done and we'll be directly working on it. All right. So just click on allow and here you can just, off it. Now here in this interface, you can see you are having block coding, you are having Python coding. So the way whichever you want to start with, you can start with. But as for this curriculum of our workshop, we will be starting with the blocks. So just click on the blocks and just skip it because I'm here to explain you. No need to worry about it. So whoever is familiar with the Scratch interface, you can understand what this beer with the lipstick means like. Right. So definitely it's known as the sprite. But we will be not working with it. Our main motto is to work with Arduino, right? So here it's basically for different purpose. It's basically for the kids who can work with building games, building stories, and all those animations. Now in the top, you will be able to find files, edit, learn, and here it's board, right? So similar to workv, we will also need to select uh, whichever board on which we want to work with. All right. So here you can see uh, we can select the board. So the board which we will be selecting today will be Arduino Uno, although we can select Arduino Mega, Arduino Nano. They all offer the same features, but they have a few differences, right? And yeah, someone is asking, Varsha, what is the difference between the WorkV and EDA Playground? Because we can simulate this. Yeah. So both are basically the similar tool. They gives you almost similar features in order to simulate, Arduino and all. But what I personally felt like is that WorkFree is one of the easiest and you know easy to learn platform where you can work with Arduino simulation, and the UI part is also pretty better than EDA Playground. All right, so let's come back, and here from this option of board you have to select Arduino Uno, and right now we are not connecting our like physical this Arduino board. So we will just leave it as it is. Just cut this pop-up, and now you can see some different features arise, right? Uh, it says Arduino Uno, where you can, it says a block which is read status of digital pin, read analog pin, play tone, connect motor, set servo, and in the also we are having actuators, which basically the motors and all. Then we are having sensors which can get the ultrasonic sensor. Then we can check the digital sensor. We are having LCD display. So if you want to see what's a LCD display looks like, I can show you. All right. So let me show you another electronics component, which is our LCD display. All right, guys. So this is a LCD display. This is a tiny LCD display. Okay, which can display any words in lines, right? So it's very tiny, but very amazing. And you can get many other displays also in the market. But I have particularly this one because I like this. It's small and pretty good. And this display you have also seen in the, uh, guess. All right. So, yeah. Okay, guys. Amazing. Uh, yeah. Yeah. So, yep. I can. I think it's yeah. Fine. I am so sorry. What's happening? Yeah. All right, guys. So I think my screen is visible now. Yeah. So now you can see that we are having digital displays. So what are these blocks all about? So those who are familiar with coding, they knows how, sometimes uh, how much difficult it's to work with coding. Just one simple error in the code and you have to scratch your head all day long to find out what's the issue with that code, what's the error in that code. All right. Uh, but with the help of scratch based or block based coding, uh, you can get rid of that particular problem. Okay. So where you just have to grab those uh, blocks. Okay. And you can code, right? So basically uh, these blocks are having different this is event block where you can set the events. This is control block where you can control anything. For example, if I want to delay or if you want to stop the execution of a program in a microcontroller, like this Arduino, right? So we have to just drag this block out and connect to it, and it will hold on the execution for 1 second. All right. You can change the timings. This session will be till 7:30, and we are almost at the end of this session, so no need to worry about that, guys. So now you can see that we can block, just drag and drop the blocks in this playground. Okay, now I have dragged this block which says set the digital pin 13. So we have seen that we are having different pins, right? Analog pin and digital pin. So right now in this digital pin, we want to set this as high. Okay, which means I'm setting it as the circuit is on, you can say, right? And then I can just make the circuit like stop for 1 second. All right. Then again, I will be using that set digital pin 13, or just change. You can change. You can choose whichever pin you want, right? So there are total 13 digital pins. So let me select just the pin number 9. All right. So if I'm selecting pin number 9, so I have to select pin number 9 here also. And if previously I have selected high, if I'm selecting high, now I will select low. So now what will happen? At first, it will set my circuit, close by giving the output high from the digital pin 9. It will wait for 1 second, and after 1 second, it will set my digital pin as low, or it will make my circuit open, right? So, for example, if I am interfacing one LED, what it will do? It will first turn the LED on. Okay, it will first turn the LED on for 1 second, and after 1 second, it will turn off my LED. Okay. Um, Now, can you tell me, if I run this code, what will happen? Uh, what can happen? Any idea? Let me give you an idea. So, what will happen is basically the code will execute, it will turn on the LED, and after 1 second, it will turn off the LED. And that's it. That's it. Nothing else. After that, our LED will be, completely staying at this stage, this stage that is low. Okay. So it will be at that state where it's turned off, and nothing is happening to it. But what if I want to blink that LED continuously? What can we do? Any idea? Yes. Yes, right guess, guys. And that is to add a forever loop, right? So we have to run this particular program in loop, where this particular set of blocks will run once, and like step by step, right, from starting from this to this to this, and again it will start from this, then this, right? But the thing is, it will be instantaneously turning on the LED once it's turned off, right? So it will be seem like it's haven't turned off, right? So for that reason, we have to also add this wait block here also. Okay, so now what will happen, uh, if we are setting this digital pin into high. So right now our circuit is in the high stage, or our circuit is closed, our LED is turned on, and after 1 second what will happen is, after 1 second our LED will be turned off. All right, and then it will again wait for 1 second, and for the 1 second our LED will be turned off. Okay, and then if I put this block inside a forever block, what will happen, my this particular block of code will run again and again and again, right? So that's basically, it's your first code to start with Arduino. All right, now this is not the end. uh, you also need to add this block which says when Arduino Uno startup, but as you can see you can't drag it here. You can face this problem. So what you can do is, you can just go to this option, stage and upload. So stage is basically for building animation, right? But right now if we go to this option, upload, right? So now you can see that we can drag this Arduino Uno, this block which says when Arduino Uno startup. So just you have to grab it and put it on the top. All right, so if we are putting this block in the top, and below it we are having a forever loop. Inside the forever loop, we are having the digital pin 9 to be high for 1 second, and then low for 1 second. And this particular logic will run over and over and over, right? And just beside this, you will be able to find the C++ programming or C++ code which this Pictoblox has written for you. Okay, so this particular application is really helpful to make you understand how the code works. Okay, how to build code by yourself with the logics, right? How to add Arduino. Yeah, that's I'm gonna tell you, right? So right now, as you are not having, I'm considering you are not having a physical Arduino. Okay, so we will be simulating this. How? Using WorkV. Okay, how? So right now you're having the code, right? You're having the code, right? You have used your logic, how you can make the circuit open and close using digital pins. You have put it in the forever loop, and you have added this when Arduino Uno starts, right? So now we are having this code, right? So what we will do is, we will just copy this code. Okay, so I have copied this code. Now what I will do is, I will simply go to WorkV. So we have already set up this environment. I have discussed how to do it, how to start with WorkV. Then here in this sketch, you just have to you know select, remove, and copy paste the code which you got from this Pictoblox. Okay, so you used your logic. Now you are having this code which you need in order to work with Arduino, and now you can simulate it, right? So I will remove all the unnecessary components, right? We are having LED. Now how to interface this LED with this Arduino? Okay, we are having the code, right? But how can I interface this with the Arduino? This is the biggest question, right? And now let me tell you, it's super easy. Okay, I know, as you are also pursuing your, most of you are pursuing engineering, right? I think all of you are, pursuing engineering. So, tell me what you have to do in order to just, turn a LED on with a battery. If you want to turn a LED on with just a battery, what you need to do? For example, I'm having this battery, and say I want to turn it on. What I will do, I will just connect the two terminals, right? Positive and negative terminals, and then I can, turn on the LED, right? You can see the LED is turning on, right? So that's what you have to do with the Arduino also, right? So you are having a LED, you have to give one positive terminal, you have to give one negative terminal. And also, I guess you should know, and also I am explaining, the Arduino is having, the LED is having two terminals, right? So one is positive and one is negative. So whichever terminal is a little bit larger, okay, that is the positive terminal, and whichever terminal is having little bit shorter length, it's your negative terminal. All right. So yeah, see, guys, I don't think if you are in a mood to learn, you don't think about the timing, right? So maybe we can extend 3 to 4 minutes extra, but definitely that's gonna worth it. Okay. So let's continue. So here also you can see in this LED, in the simulation of WOOFy, we can find out that one terminal is slightly bigger, right? So this terminal, which is little bit tilt, it's your positive terminal, and whichever is shorter length, it's your negative terminal. So in the Arduino, what we have to do is the negative terminal always goes to the ground. Okay, and you just have to click here, and you have to you will get this wire like structure, and you can connect it with the ground. Okay, so you are having two ground pins in your Arduino. You can select any one of it, and you can just connect, right? uh, okay, now we are having the positive terminal. What we have to do is, whichever pin we have selected from the Pictoblox, right, from here, digital pin. So it can be any of the 13 pins. So if we are having the ninth pin, so we have to connect this positive terminal with this 9 number pin, right? And once you connect it, you are done. So you have successfully interfaced a LED with the Arduino board. All right. So now how to run it? To run it, you just have to click on this start the simulation. And if your code is right, you can uh, get the output. So let's see whether we are uh, going fine or not, or we have did some mistake. So it's running, and you can see, voila! So successfully our LED has been interfaced with the microcontroller, and the way we wanted to turn on this LED, it's working as fine as cake, right? So our LED is blinking with the duration of 1 second. So after 1 second, our turning is LED is turning on, and after 1 second, it's turning off. Now you guys tell me, should I interface the same thing in a real microcontroller? I'm gonna do that, but we are running out of time. So if okay, okay, that's amazing. I think, Ovis, we can explain it using, real components. Okay, so it will be, better. Okay, so let's do it, and you will be, understanding that last point which we were discussing. So let me just share my screen. Uh, okay, all right. So yeah. Can you see my screen? Right. Can you see the other camera view? Right. So I think you can see the other camera view. And here, now we will be using this breadboard. All right. So how can we use the breadboard? See, in the breadboard, uh, the series parallel connections, right? So all this, you can see small, small holes which are there. They are connected. Like here, all the rows, okay, all the columns are connected. So in these holes, all the rows are connected, right? So this all are connected. If I want to explain it to you, so if you are connecting something here, they all are connected, right? But this block or this and this are not connected, right? So here all the columns are connected, but in the top here not all the columns are connected, here the rows are connected. So these rows are connected with each other. So if you put something here and here, they will be short, right? So if you are connecting something in the top, you have to connect it like this in the row, and here all the blocks are connected in the columns, right? Now what I will do is I will just fix my LED. So this is my positive terminal, this is my negative terminal, all right? So I will put one terminal in this hole and another in a different hole, right? Right. So I have fixed this LED. Now I can use any of this hole from this row to give it a connection, right? So this is the positive and this is the negative, right? So this is the positive terminal, this is the negative terminal, and I will use some connecting wires, right? So I'm using the connecting male to male where I am having pin in both the sides, right? So I will connect one of the hole from this row to give it the positive terminal output, and I will connect any of the hole from this row to connect with the negative or the ground of this LED, right? So this negative terminal will always go inside the ground. Okay, so here in the power supply, you can see there is a GND, that is the ground, right? So in this ground, I have to connect the negative terminal of the LED, all right? And I have to connect uh, the positive terminal in the pin, in the digital pin, which we have selected while, doing our code, right? So I have selected the pin number 9. So I will just, you know, put that connecting wires to the pin number 9. And once I have, done with this, I have done my interfacing. I have done with interfacing the LED with the Arduino, right? So now what will happen is this digital pin act as a 5-volt pin. Okay, so it gives the 5-volt output whenever the circuit is closed, right? So now what I will do is I will be using a connector. Uh, just give me a second, guys. Let me get the connectors. Yeah, I got it. Right. So this is the connector which you have to, connect it in this port of the microcontroller. Then you can just, put that USB cable inside your computer. All right. Now, uh, let me share my screen. Okay. So you can see the Pictoblox, right? So in the Pictoblox, now you can see an option where you can connect, right? So just click on this connect. You will be able to see the ports which are available in your device, right? So I guess this is the port which I have connected. So whenever you interface one Arduino board, you will get this, COM7, COM6, ports. So I will just connect with it. Yeah, so my port is connected. And now if I click on just this portion, upload the code, it will upload the code into my Arduino. So let me show you. I think you can see. Mm, yeah, I guess here I'm having the display capture. PT. Yeah, yeah. So you can see, right, my Arduino board and also my Pictoblock screen. So if I just click on this upload code button, it will upload the code inside my microcontroller or the Arduino. All right. All right. So upload in the process. And finally, our code has been uploaded in the Arduino. And you can see in this, our LED is blinking. Just if you can see, our LED is blinking now. Okay, so the same thing which we have done in the Wiki or in the simulation, now we are doing it in the real life, hardware. Okay, which is our Arduino and a real life LED. So guys, this is all about our today's session. And tell me, did you like it? The way the approach which we have taken in order to make you understand the topics. So, was it good for you? And how much helpful it was for you? So, let me just get, uh, okay, uh, yeah, guys. So, yeah. All right, guys. Uh, so, we are now at the end of our session, and I have given my best to make you understand all the concepts as much easy as possible. And I want you guys to also explore the Pictoblox uh, by your own, and also interfacing some other components like push button with the LED or a register with a LED. So in the next session, we'll be starting with the importance of register, and then we will be moving forward towards how to interface other sensors, and then how to interface servo motors and those things, right? So most welcome, and let me know in the comment section uh, how much you like this session, and that will be a feedback for me. And if at all you find out something which I can improve in order to make you understand much easier way, I will definitely implement that in my teaching style. So let me know, guys, what are your feedbacks. Okay, that's really that means a lot to me. Amazing. Yeah, next session timing and date will be announced in the WhatsApp group. So make sure to follow the workshop group daily, and maybe tomorrow, within tomorrow, you will be getting the complete schedule of when will be the next sessions and their timings and every information. So be with us, guys, and definitely we're gonna rock. And yeah, tomorrow you will be also getting the assignments which you have to submit. All right. And once you submit the assignment, your attendance will be marked, and your score as per the score and as per the how much assignments you have done, we will be giving you the final certificate. And although, if at all you ask me, uh, you know, the main motto of this session is about to make you learn, to make you understand the concept, and to make you realize that everything, this robotics, electronics, these are very easy topics and very interesting topic. So I have taken this responsibility to, bring that interest into this particular topic. Okay, so thank you so much, guys. Thank you so much. You know it's really great feeling when I see this type of responses from you. So you have to submit the assignment in the Google form only. We will be creating one Google form where all the assignment questions will be there, and maybe you have to do some hands-on activities where you have to interface a LED by yourself and send the screenshots, and so that way you will be getting a hands-on experience, right? Oh, so and that's basically what we want as the output. So thank you so much. No, it's not in the WhatsApp group. We will be sharing one Google form, like where we will be adding all the assignment questions, and you have to just submit there, and that way your attendance will be marked. All right, guys. So that's all for today, and hope to see you soon. And the next session will be very soon. Uh, so no need to worry. And the date will be announced prior the session. So we will give you some time where you can research by yourself. You can, work with this Pictoblox, then work V by yourself. You explore it, and let me also know in the next class what you have did by yourself. after gaining this knowledge of Pictoblox, block-based coding, and how to simulate it, or if you are having your if you buy your Arduino kit, if you have tried to implement it in the real life hardwares also. So that's all, guys. Thank you so much, and thank you so much for your patience in the starting. And we will make sure in the next time we are all set up, we are all ready. And thank you, guys. And bye bye. See you again. Have a good day.